Hello everyone, today we'll be discussing the remaining parts of the paper 2, variant 1 of May June 2021 for this mathematics paper. And question 10 right now is focused on transformation of shapes. So here we can see a diagram of three different triangles, and the question asks you to describe fully the single transformation that maps triangle A onto triangle B, triangle A onto triangle C. A1 focus is talking about the all these have to be done via a single transformation, and A1 is a triangle A onto triangle B, these two right here as I've highlighted. In looking at this, you could clearly tell that it is a form of rotation. When you rotate your shape about 90 degrees, it actually takes the form of triangle B, right? And so A1 is a form of rotation, a 90 degrees clock and actually 90 degrees anti-clockwise, so or counterclockwise, whatever you want to call it. And then that's your answer for that, but you also need to specify a center of rotation. To do this, you must remember how you do it to begin with. You should take the points that you're rotating around, because you are rotating each point, and when you rotate this point A to 90 degrees, it gives you this point A prime. So let's draw a line, straight line. So you should review your notes about this. And then let's say B, it rotates, it becomes this B prime. So draw a straight line to match these two lines. And then finally C and C prime, draw a line to match these two, straight line. Draw a line to match these two, and then for each straight line you're gonna draw a perpendicular bisector. A perpendicular bisector is a line that bisects the straight lines, each straight line, meaning crosses at 90 degrees, and the length, when you divide the lines, they must be equal in length. So we can make a rough approximation. So about here, for A, it's about here, and then we draw a 90 degrees to go up, something like this. And then the other ones here would be, if you use a tracing paper, it would be really easy. But you can draw a bisector about here, and then another one here for B in the middle. And actually they all cross this value here, 0 minus 1. If you draw it more accurately, it actually depends on the scale of the paper, but if you do a rough approximation, it does go up to 0 minus 1, and that's the correct answer for the center of rotation. So make sure you draw the perpendicular bisectors properly, and it also depends on the paper itself, how it scales when you look on it. So anyway, that's done. I'm gonna remove it. Now triangle A onto triangle C. So triangle C is that small triangle on the right there, top right there. And as you can see, it clearly falls under a scaling transformation. So it reduces in size. When it reduces in size or increases in size, it's called enlargement. So there's no other word for reduction of size. It's still called enlargement. So this is actually enlargement. And you need to know the center of enlargement and the scale factor. So to do this, let's look first at the scale factor. We know it's going to be less than 1 because it's small. You can specify points. So A, B, C. The length AB is from -6 to -3, so that size is 3. Now if we look at distance between C and A, that's from -3 to -9. So that's a magnitude of 6 length. Now if we look here, this one has size of 1 and this one has size of 3. So clearly you can see that let's rewrite this a little. So this has length of 6, this has length of 3. Clearly you can see that this should be length of 3, sorry, and this is -9 to -3. Sorry, this length is 2. What am I saying? This length is 2, so 1, 2. Yep. So clearly you can see that there is a scalar multiplication of 1 on 3. So when you take 3, you multiply by 1 on 3, that gives you 1. That's this length here. And then 6, you multiply by 1 on 3, that gives you 2. So that's 2 right here. So that then your scaling factor is 1 on 3. Finally, you need to look at the center of enlargement. To do this, you draw lines to the transformed points, because you are doing point transformations. Go here like this, draw it to each line, and look at where it converges, where each point meets. So I'm going to draw the line out for much longer, just to make it easier to see where it meets. So again, it will be easier when you have an actual physical paper. Now I'm going to draw it for every single one. So B here matches to this. I'm going to draw it out here. Oops. Okay, that was quite bad, so I'm going to redo it. There we go. Something of that sort. Should be done properly. We go here, and then here we go. Okay, as you can see, all 3 lines converges at this point here, 6, 6, 6. So that's actually your center of enlargement. So now with this you can figure out that the center of enlargement is the coordinates 6, 6. So that's your A2 done. Now you're going to draw, for B it's about translation. So this is both horizontal and vertical translation by a vector here or a matrix here. That means you go right by 2 and go up by 10. So now if you look at the coordinates, it's going to be easier to view it as points. So record the points of each individual triangle. Record the points of each individual triangle. So here, each individual point of the triangle. So this is -6 and -9, and this is -9 and -3, and this is -6 and -3. Then we're going to translate it by 210. So 2 to the right. So let's take this point first. 2 to the right, that gives you -4, and up by 10, that gives you 7. So -4, 7, that's here. Oops, no. that's here. Okay, let's record the point. Minus 6 minus 9, so add 2, that's minus 4. And then minus 9, you add 10, so that gives you a 1, so that's here. And then minus 9 minus 3, so you add 2, that's minus 7. No, that's sorry, I reversed it. Minus 3 minus 9, so you add 2, that's minus 1, so that's along this line. Then minus 9, you add 10, so that's minus 1. So this is your new triangle after the translation. So hopefully that's clear, and that's basically done for the transformation questions. Now we're going to continue to question 11. Ask you to simplify an exponent 4ab to the 5th power all to the 4. So the rule is that you need to distribute the power into all of these. So 4ab 5 to the 4th, that equals to 4 to the 4th, a to the 4th, b to the 5th to the 4th. And the exponent rule here is that these two multiply each other. So 4 to the 4th, a to the 4th, b, 5 times 4, that's 20. So that's your answer, but you need to simplify this. This one you can simplify. 4 to the 4th, use a calculator, it's 256. A to the 4th and b to the 20. So that's your final answer. Now b here, it asks you to find the value of p. So we're going to simplify it a little bit first. So P1/3, you divide both sides by 2, that gives you 3. And now the trick here is 1/3 is essentially the cubed root of p. So you bring it over, that gives you so it implies that p is the 3 cubed. Hopefully that's clear. When you square root, when it's 1/2, it's a square root, so you bring it over, it's a square. When you put a cube root, you bring it over, it's a cube. So 3 cubed is 27, so that's your answer there. Now I'll ask you here to find the value of t, this t here. So 81 squared, let's rewrite this, 3 to the t, that equals to 9. So now we're gonna do some rearrangement. I want to divide both sides by 9. That may help a little bit. So if I divide both sides by 9, that gives you 1 here. So 9 times, we know that 81 is 9 squared. So 9 squared and then squared again, so that's 9 to the 4th. Divided by 9 times 3 to the t, that equals to 1, right? So this one cancels, becomes 3, because you can 4 minus 1, right? So it's 9 cubed over 3t. Now you want to bring it over, so 3 to the t, that equals to 9 cubed. Hopefully that's clear. And then 3 to the t, that equals to 9 cubed. Now you know that 9 is 3 squared, so 3 to the t, that equals to 3 squared times 6 times 3 here. So that's 2 times 3, that's 6. So you finally get, implies that t equals to 6. Okay, so that's your answer there. So I'm going to write it clearly here, the working that I did. 81 squared over 3t equals to 9. First I divided both sides by 9. Divide by 9. So then, and I also take this, right? 81 squared equals to 9 squared equals to 9 to the 4th. So once I divided both sides, I got 9 cubed. 3 to the t equals to 1. And then I brought it over. 3t equals to 9 cubed over 1, or 9 cubed. and then this is equals to 3 to the 2 times 3, right? 3 squared times 3, 3 to the 6. So then that's how I got t equals to 6. Okay. Now let's go on to number 12. It says here the profit a company makes decreases exponentially at a rate of 0.9% per year. So if you look at the exponential rate formula, it tells you that it goes of the form some constant times by 1 minus r to the power of t. T is time and r is the factor, so the rate factor. So the rate here is 0.9% per year. So you know that the rate should be something like 0.9 over 100, right, to express it into fractional form. And he says here in 2014 the profit was 9500, and the profit now decreases from 2014 every year. So the base case is 9500. So the initial time, so at t equals to 0, meaning initially a should be 9500. That's your initial value. So let's set it up properly. So 9500, you know that r is 0.9 over 100. So let's put it as dollar sign, the profit. So this is your profit after a certain number of times. So is this calculate the profit in 2019? Between 2014 and 2019 there are 5 years. So that means from t equals 0, t equals 1, t equals 2, t equals 3, it's 5 years in between. So that has to be, the exponent t has to be 5. So once you solve this, you get the profit in 2019, and it should come out to 9080 something, and that's your answer. Hopefully that's clear. And I'm gonna move on. Now this is about scaling. It says here on the map a lake has an area of 32 cm square. So let's pretend it's a square for a second. This means that it's going to have square root of 32 cm, square root of 32 cm. And this gives you the area of 32 cm squared. Okay, and that makes sense because it's very small, obviously, because it's a map. And you see the scale of the map is 1 to 224,000. So essentially the area will be 24,000 square in length. It's magnified by that number. So you say calculate the actual area of the lake. Give your answer in km square. So the difficulty here is to convert it properly. And here we're going to do it in by knowing the scaling laws. Between cm squared and km squared, there is a meter squared. So let's convert it to meter squared first. 32 cm squared, and in 100 cm there's 1 meter. So in a meter squared there's 100 squared. So convert it, you can use remember the formulas or whatever. So that's 1 meter squared. So you have 100 meters, you have to divide by 100, and then because it's squared, so you do 100 again, so it's 100 squared. So 32 divided by 100 squared, and then 1 meter has 1000 meters has 1 km. So again you divide it again by 1000 squared to get it into km squared. Hopefully that's clear. So 32 over 100 squared times 1000 squared, that's your that gives you your area in km squared, but of the map, of the lake area in the map. Now they ask you to scale it. The scale is 24,000, so you need to multiply this by 24,000 times 24,000, because this scale is in centimeters. So 1 centimeter is 24,000 centimeter. to put it into square, you need to put it into area, you need to square it. So that's why you square this here, and that essentially gives you your answer. And it should come out as about 1.8432 if you do your calculations right. I'm going to, if you put 1000 square, yeah, that should be right. So that's your answer here, 1.8432 kilometers square. Okay, so hopefully that makes sense. Now question 14 is asking you y is directly proportional to the square root of x minus 3. So put like this and then square root, and it says here when x is 28, y is 20, find y when x equals 39. So directly proportional means y equals to some constant square root of x minus 3, right? And it says here when x is 28, y is 20. So we need to find k here. So 20 equals to k squared, plus just substitute in 28 minus 3, that's k 25, or 5k. Square root of 25 is 5. Now you're going to divide both sides by 5. So 20 divided by 5 is 4. So that's your k. So you found k. Now I ask you to find y when x equals 39. So y equals to 4 times, now substitute it 39 here. 39 minus 3, that's 36. So square root of 36 is 6. So 6 times 4, that's 24. So y is 24. That's your answer. So 15 here, question 15, make h the subject of the formula 2mh equals to g times 1 minus h. So let's start by expanding this side first. G times 1 is g, minus g times h, so gh. Now you need to make h the subject, so you need to make h equals to blah blah blah. So to do this, you rearrange here first. You can notice that both sides here has a factor h, so you can actually remove it by factorizing. So first you bring it over, 2mh plus gh equals to g. Now you can actually factor out h, okay, because common factor, h, 2m, right, plus g equals to g. See, that makes sense. H times 2m, that's 2mh, h times g, that's gh, that equals to g. Now you can take this and divide it here, right, divide both sides by 2m plus g, so you get g equals to 2m plus g. So that's your answer. Hopefully that's simple and makes sense. Okay, now question 16 here, you're given a straight line and you're asked to find the gradient of the line. So to find the gradient, you pick 2 points and then you do the rise over run. So y2 minus y1 over x2 minus x1. So we're going to take 2 easy points, right, that you can see properly. The ones I see here right now is this 4 minus 1, that's very clear to me. And here there's another one here, that's 0, 2, that's very clear to me as well. So the gradient is y2 minus y1 over x2 minus x1, or rise over run. So we take this 4 minus 1, so minus 1 is the y2, minus 2, because 2 here, and the x2, that's 4, and minus 0. So you get minus 3 on 4. So that's your gradient. So think about it, whether it makes sense. Your line is decreasing, so obviously it has a negative gradient, right? That makes sense. So that should make sense. If it's increasing like this, it should have a positive gradient. Okay, now, so that makes sense. Now I ask you to find the equation of the line in the form y equals mx plus c. So c here is the y-intercept. It's y-intercept, and you know what the y-intercept is. That's when x equals to 0, what the y value is, and y value is 2. So c is 2. And to check that makes sense, you can just substitute it in, right? You have 3 on 4 x plus c. Now you know the point x equals to 0, so this vanishes. Then y is 2 here, then you get 2 equals to c. So your equation is like this. Okay, that's your y-intercept. Now I ask you to find the equation of a line that is perpendicular to the line. I'll pass it through the point 12 minus 7. When you see perpendicular, you immediately think of the equation m1 m2 equals to minus 1. That tells you that when you multiply both gradients, that gives you minus 1. So you know m1, that's minus 3 on 4. So m2 is minus 1 over minus 3 on 4. Put it in the calculator or whatever. That should give you 4 on 3. So essentially bring it up. Okay. So a positive gradient here. Now, so this perpendicular is 4 on 3 plus c. Oh, let's call it A. Passes through the point 12 minus 7, so substitute that in. 4 on 3 times 12 plus A equals to minus 7. So you do the algebra, you take A minus 7 plus 48 over 3. That gives you 48 over 3, that's 16. Sorry, should be minus. Made a mistake there. Minus 7 minus, this is 16. So minus 7 minus 16, that's minus 23. So your perpendicular line is 4 and 3x minus 23. Okay. Now we're going to continue here. So you see a bag, so this is a probability question. A bag contains 3 blue buttons, so let's put 3 blue, 8 white, and 5 red. 2 buttons are picked at random from the bag without replacement. So every time you pick one, the amount in the bag is decreasing. So as you work out the probability that the 2 buttons are either both red or both white. So either is a condition here. So you can add the probabilities. So let's start with the first one first. It's not and the 2 buttons are not and both red and both white. So you only pick 2 buttons. So the probability to get one red button when you pick out initially should be 5 over 3 times 8, 3 plus 8 plus 5, right? There are a total of 16 buttons here. So 5 out of 16, that's the probability of getting red in the first round. And then you need to both red, right? So once you've taken one, it reduces. So that's 4 red buttons left over a 15 total buttons. Okay? And then both white, so you need to add the other part. There are a total of 8 buttons, 8 white buttons out of 16 buttons. So let's say you drew 8, you got a white button, and the second one it needs to be white again. So that's 7 remaining and over 15. So indeed this gives you should give you 19 over 60. Should make sense. Now let's put it into the calculator and see if that's right. Yep, 19 over 60. So that's your answer right now. Okay, hopefully that makes sense. So this is for the white buttons, and this is both red, this is both white. Okay, so it gives you 19 out of 60. That's your answer right now. Now let's look at question 18. Now this is about vectors. It says here S is a point on PQ such that PS on SQ is 4 and 5. So meaning that PS is smaller than SQ, right? So this length here is 4 on 9, 4 plus 5, PQ. And this is, to SQ is 5 on 9, PQ. Okay, this length is smaller than that length. So to find OS,